Hello friends, last lecture we have learned in biogenesis the biosynthesis of chalcones and some compounds from the flavonoids. Okay, you know the moiety of the chalcone, and from that chalcone we can easily prepare the flavonoids. Today we will learn to synthesize the very important compound which is stilbene. Okay, stilbenes. This stilbene we can prepare because which is very resemblance to the flavonoids, and also we will learn some compound from isoflavonoids. Okay, obviously I will write down the starting material first, which is 4-hydroxycinnamoyl coenzyme. I will write down accordingly. This is the OH, then this double bond, then this CO and COAS. Okay, so this is the name 4-hydroxy cinnamoyl coenzyme. Okay, so this is the starting material. From it, with the help of 3 molecule of the malonyl coenzyme, we can prepare the interesting intermediate. I will write down the structure. OH, then this double bond as such, this carbonyl group, and now from here it will attach another CO, then CH2, then another CO, then CH2, then another CO and SCOA. Okay, so this is the intermediate, because how many malonyl compound has joined? 3 malonyl has been joined here, right? Then the same this compound we can write in this way also. This double bond, this OH, so alternate carbonyl group, right? So this CO, SCOA. Okay, so both these compounds are same. Okay, so from this compound, why we have written this? Because there is chances of break and there will be a decarboxylation. So CO2. Okay, so and we can say this is aldol type of reaction. Okay, and after aldol type of reaction, we can prepare it. There will be cyclization. Okay, and these 2 hydroxy group will be there. The name is RES VERA trol, TROL, resveratrol, or this is the compound of stilbene which we are looking for. Okay, from this compound or this intermediate, we can prepare the chalcone also. So the both are the same, so I will write down this one. Okay, so this is the what yesterday we have used is chalcone synthase. Okay, actually this is Claisen type of reaction, right? So what you will get, I will write down this compound here, chalcone type of compound. So 3 hydroxy, then here double bond, here is also double bond, in last lecture we have already learned the things, right? Okay, so I would say this is a chalcone. Okay, from this chalcone actually we can prepare flavanone, Michael type of nucleophilic attack of OH onto this alpha beta unsaturation ketone, right? So this lone pair of OH will attack on this carbon, then this double bond will shift here and it will go here, right? So how the product will be? This OH, so this moiety will form double bond O, this CH, this benzene ring and OH, and hope you remember the compound which is flavanone. Flavanone, or in another name naringenin. Right? There is possibility that we have already learned how to synthesize from chalcone to flavanone. I would like to write down another compound. From this flavanone we can prepare after oxidation. I will write down simply oxidation. So there is a possibility of another hydroxylation. Okay, so I will write down directly the compound. First we will write down this basic, okay, these bonds, then these bonds are there, this 2 hydroxy group was already there. So after oxidation what will happen? 1 hydroxy group will insert here and another hydroxy group will insert in this position. So the name of this compound is taxifolene. What is the name? Which is taxifolene. Then after reduction of this compound, this taxifolene, reduction means NADPH, right? And what we will get is, again I will write down the basic thing. This is the flavonoid type of compound. This 2 hydroxy group will as such, this hydroxy group will as such, here OH and here OH. So what happen here? In reduction, this carbonyl group will be reduced into CH2, right? So here only CH2 group. I will write down H and H. So the name of this compound is catechin. The name of this compound is catechin. Okay. Again, from this flavonoid type of compound, we can also prepare the isoflavonoid, right? We have already learned, but we will revise it on different way, because I saw one research paper, and based on this research paper we will learn these things, right? So first I will write down the basic thing. This oxygen, then this double bond O, then this phenyl moiety and OH, right? And here instead of OH they have written here R. R may be H or R may be OH. When R is H, then the name of this compound is liquid-retingenin. Okay, and when R is equal to OH, the name which already known, naringenin. Understand? So this we have written very as a general term, right? So in presence of NADPH and this FeC double bond O enzyme, okay, there is a possibility of this hydrogen will be attack on here, okay, and what will happen here? There will be formation of a radical formation. I will write down directly the compound. This R, this OH, triple bond, this oxygen, this double bond O, and here this is benzene ring. Okay, so there will be formation of a radical. This radical will this will be very active, so there is chances of breaking of this bond. Okay, and what will happen? There will be 1,2 RL migration will happen. Okay, and due to this migration, what we will get? This OH, this R, this double bond O, and rather than here, what will happen? In this position you will get this phenyl migration will happen, and there will be formation of a radical. So this is what type of compound? Isoflavonoid type of compound, right? And then this radical will be stabilized by this enzyme having hydrogen group is there. So it will attack here and it will here, like this, right? So what we will get is the final compound. Yes, so there is a possibility this OH, this R, then this O, then this double bond, then here is OH, right? And instead of here radical, there will be formation of hydroxy group which is in above the plane. Then this OH is unstable. So there will be dehydration, or I can say minus H2O. Okay, and what we will get is here are this basic things. Okay, and here instead of OH, this group will remove and there will be formation of double bond. And now we can say the name of this compound is isoflavonoid. Here when R is equal to H, the name is diadzenin. Okay, and when R is equal to OH, the name is genistein. Okay, so almost we saw 3-4 new things today. Okay, so first we will see, or we will revise what we have learned. See, the thing is, we have started from this 4-hydroxycinnamyl coenzyme, which is the known compound for us. Okay, from phenylalanine we can prepare this compound. Then the 3 molecule of malonyl coenzyme, we can prepare this intermediate. Okay, this intermediate we can write on this way also. Okay, from this compound there will be decarboxylation, and after decarboxylation there will be aldol type of condensation within the molecule. Okay, and in this aldol condensation there will be formation of stilbene, Stilbene. Okay, stilbene, and the name is resveratrol. Okay, whatever pronunciation is there, try to recall it. Very good. Okay, so this is the important. Then again from this intermediate we can use the chalcone synthesis as an enzyme, and after Claisen type of condensation you will get the chalcone compound. Okay, and this is the structure of chalcone. From this chalcone there is a formation of ring. Okay, and how it will form we have already shown, right? And you will get the flavanone type of compound, and the name of this flavanone type of compound is naringenin. Okay, from this naringenin after oxidation you will get, you have to insert how many OH group? 2 OH group from this position as well as this, and you will get this taxipholine. Okay, from this taxipholine after reduction this carbonyl group will reduce, and what we will get is catechin. Okay, what we will get is catechin, right? Then in another place we can also prepare isoflavonoid from this naringenin. So we have written here naringenin. From this naringenin after reduction there will be formation of a radical. This radical is unstable, so this group will migrate on this position. Okay, it's called as 1,2 RL migration, and after migration what you will get here is there will be a hydroxy compound. Okay, and it will be above the plane, and this hydroxy compound is unstable, so there will be dehydration, and after dehydration what you will get is the isoflavonoid, right? And these 2 type of isoflavonoid which is dead gene and genistein, right. So, we have learned today how to synthesize chalcone, how to synthesize flavanone, and how to synthesize isoflavonoid, right. So, this is part 2. We can say the synthesis of stilbene, flavonoid and isoflavonoid, right. Try to recall, try to make your own notes, add whatever points you would like in different type of books or in Google, and prepare your own notes very nicely and precisely. Again, I will appeal you to try to recollect the questions from the different questions paper from the universities, and make your question bank as well. Thank you.